Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 2 paper from autumn 2022. This paper is worth 120 marks in total, and this is the second video of 6. It will focus on questions 5 to 8, which account for 22 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 5. 9 shapes are shown below. Complete the following sentences. Shapes something and something only have 2 lines of symmetry. So lines of symmetry are lines we can draw that split the shape exactly in the middle. Okay, so they only have 2 lines of symmetry. So I'm going to say that shape D and shape E, because a rectangle has a line of symmetry here and here, but we don't include the diagonals because not all of the sides of the shape are equal. Shape E, we could split it down the middle here, but we could also split it down the middle here, any other point, and we wouldn't have symmetry on the other side. So D and E have 2 lines of symmetry. So this shape something has rotational symmetry of order 4. So rotational symmetry means that if we turn the shape 360 degrees, it fits into itself exactly 4 times. Well, that's going to be shape B, because B is a square and all 4 sides of the square are the same. So when we turn it, each side will slot onto the other, and it'll happen 4 times in a 360 degree turn. Okay, the next one, shapes something and something are congruent. So congruent means exactly the same, okay? They can be rotated, but they have to be exactly the same dimension-wise. So A and H are congruent, they're the same shape. It's just that H has got a different rotation, but the size of the shapes have not changed, they match. And then the last one, shapes something and something are similar but not congruent. So remember, congruent means they don't change size in any way, but they can be rotated. Similar shapes means that they could change size, okay, but they change size within a particular proportion. So we're going to go with C and G. They are both pentagons, but G is bigger than C, so it could be an enlargement of C. Question 6. The table below shows part of a train timetable between Portsmouth Harbour and London Waterloo. So these are the train times: Portsmouth Harbour, London Waterloo. So this is one train. So it leaves at 6:15 and arrives at 7:53. This is another train, the next train, the next train, the next train, the next train, and the next train. That's how timetables work. Part A. Elise catches the 08:45 train from Portsmouth Harbour to London Waterloo. How long should her train journey take? So she catches a 08:45 train. So that's this train here. So this train leaves Portsmouth Harbour at 8:45 but arrives at London Waterloo at 10:29. So we're going from 8:45 to 10:29. So we're going to do this in parts. So to get from 8:45, I can't write, to the next hour, which would be 9 o'clock, that's a 15-minute journey. Okay, so that's 15 minutes. And then to get from 9 o'clock to the next hour, which would be 10 o'clock, is 1 hour. And then we're going from 10 o'clock to 10:29. So from 10 o'clock to 10:29, that's another 29 minutes. So we've got 1 hour, and then we've got 15 plus 29 minutes. Which is 44 minutes. So it takes 1 hour, 44 minutes. Part B. Paul lives in Petersfield. So he lives in Petersfield and he works in Guildford. He starts work at 10 a.m. It takes him 15 minutes to walk from the station to work. Paul needs to arrive at work on time. What is the time of the latest train from Petersfield he can take? Okay, so he starts work at 10 o'clock and he lives in Petersfield and he's going to Guildford. So we need to look at trains that arrive to Guildford before 10 o'clock, but allowing him 15 minutes to walk from the train station in Guildford when he arrives to where it is that he works. Okay, so 10 a.m. take away 15 minutes means 9:45 a.m. at the latest he needs to arrive. So we're going to Guildford, so let's have a look. So we've got 9:18, we've got 9:48. 9:48 would be too late because he needs to arrive at the latest at 9:45 because then he's got to walk another 15 minutes to get to work for 10 o'clock. So it won't be this train, this must be the latest train that he catches. Okay, and the time of the latest train from Petersfield, well, where this is our train here, we're looking for Petersfield, so we're going up to this part of the train timetable here. So it's Petersfield, and this is the same train getting him there to Guildford for 9:18. So the time of the latest train he could catch is the 08:47 train. Question 7. Georgia is going on holiday to France. She takes one large suitcase and one piece of hand luggage. The graph below can be used to convert between kilograms and pounds. So we've got pounds and kilograms. Part A. Georgia's suitcase has a mass of 24 kilograms. What is the mass of the suitcase in pounds? So 24 kilograms. So we're going to read across this horizontal axis because that's the kilograms. We're going to 24. So we've got 20 and then 25. Between 20 and 25 is 5, but we have 10 small squares. So 2 small squares is equal to 1. So 24 is 2, 4, 6. 24 is here. Okay, so we're going to mark up from 24 to the graph that's been drawn. And then we're going to also read across. I've done this in pen so you can see it. I would recommend you do it in pencil just in case you make a mistake. So then we're going to read this scale here. So from 50 to 60 is 10. There are 10 little squares, so each square must be worth 1. So that's 51, 52. Then we're halfway between 52 and 53. But it's my line's gone down slightly, so I'm going to go 53. So it's 53 pounds. Okay, the next part. Her hand luggage has a mass of 13 pounds. What is the mass of her hand luggage in kilograms? So we're starting on this axis now, 13 pounds. So I'm going to go 10, 11, 12, 13. Read across. And then read down. So we need to remember that this bottom scale, 2 of those small squares was equal to 1. So that gets us to 6. So it would be 6 kilograms. A car hire company in France uses the following formula to calculate costs in euros. This is the formula to calculate costs in euros. So car hire cost equals €11.25 multiplied by the number of days of car hire, add the insurance. So for part 1, Georgia decides to hire a car for 8 days. The insurance will cost her €95. Calculate the cost of Georgia's car hire. So we're substituting in these values into this formula. So car hire equals euros of 11.25 multiplied by the number of days, which is 8. And then we're going to add the cost of insurance, which is €95. But remember, order of operations, we need to do that multiplication first. So even though I'm going to stick this in my calculator, I'm going to pop a bracket around that just to be safe. So 11.25 multiplied by 8, add the £95 for the insurance, is €185. I said £95, I meant €95. Part 2. Mina is also hiring a car from the same company. She has £270 to spend on hire car. Insurance will cost her €126. She wants to hire the car for as many days as possible. For how many whole days can Mina afford to hire the car? We are working in euros here. I don't know why I keep saying pounds. I must be tired. Okay, so we want to see how many days she can hire the car for. So we are going to substitute what we know. So insurance is going to cost her €126. So instead of adding the insurance, we're going to subtract it from how much she has to spend this time. So 270 subtract 126. So she has €144 to spend. It's 11.25 euros per day. So we're going to divide this by 11.25 to see how many whole days. It's still in my calculator. Divide by 11.25. So that's 12.8. Can't see my calculator very well today. So 12.8. We want whole days. So 12 days is what she can afford to hire it for. Question 8. Malik is planning a birthday party for 25 children. He can choose either a swimming party or an adventure centre party. So we've got a swimming party and the costs here, an adventure centre party and the costs here. Malik works out the total cost for each party. He chooses the cheaper of the parties. Which party does Malik choose? So we have to select swimming or adventure centre. We've got to show all of our working out. And they've given us a section for swimming party and adventure centre party. So we've got a section for each set of our working out. We're not going to tick a box randomly. We're going to do some working out. So we have 25 children in total. So let's start with the swimming party. So it's £320 for 20 children and then £7.25 for each additional child. So for 20 children, it's £320. But then we've got 25 children. For those other 5 children, it's going to be £7.25 times 5. So £36.25. So in total, we've got £320 plus £36.25. So that's £356.25. However, there's a special offer. He gets 1/3 off the total cost of the party. So we want 1/3 of £356.25. So we're going to divide it by 3. We divide by the bottom and then multiply by the top. So let's divide by 3. I'm not multiplying by 1 on the top because it would just give me the same answer anyway. So divided by 3 is £118.75. It's 1/3 off. Here, look, that's the important thing. So we need to take that 1/3 away from the total cost. So £356.25 subtract the 1/3. Which is £237.50. So that's the total cost for the swimming party. Let's do the same for the adventure centre party and then we can see which would be cheapest. So the adventure centre party is £13.60 per child, 15% off the total cost for groups of more than 20. So let's deal with the per child. We have 25 children and it's £13.60 each. So 25 times £13.60 is £340. But then it says we get 15% off the total cost for groups of more than 20. So we have 25, we have more than 20. So we're going to find 15% and take it off that total cost. Okay, so to find 15%, I'm going to find 10% and 5%, and then I'm going to add those together. To find 10%, we divide by 10. And to find 5%, I do half of my 10%. So 34 divided by 2. Anything you need to do calculating wise, do it in your calculator, guys, to be safe. We're going to add those together. So 17 plus 34 is 51. So that's our 15%. And we're taking that off the total cost. So 340, take away the 51, is 289. So we need to compare the total cost. So this is the total cost for the swimming party. This is the total cost for the adventure centre. Okay, the adventure centre is clearly more, so the swimming party is cheaper. So we're going to tick that box.